Although, yeah, so the talk is called Striving for Simplicity. Before we get started, I do have a couple of disclaimers. One of them is related to what he just said. I am Italian, I tend to talk a lot. So hopefully we'll still have time for questions at the very end. If you see me talking really fast, it's probably because I realize that I'm running out of time. The second one is that I've been talking with some people around the conference, and every time they asked me what I was going to speak about, I said the title of the talk, and they were like overly excited about the title, said that it was a catchy title, it's a hard problem and stuff like that. So hopefully I'm going to meet your expectations. Just want to say it like super clear right now that I'm not exception to the rest of 8 billion people that went through COVID and became super enlightened and philosophical and all those things. I also did sourdough and all those things, which basically means that I am going to do a talk that is very philosophical. You're not going to find here like a checklist of things that you're just going to follow and are going to solve all of your problems. What you're going to find here is hopefully some ideas, mental models, and things that you can apply and like think about that will help you reason about what simplicity actually is and how to approach it. I do not hold the answers to all the questions that you might have, but hopefully some of my experience will help you out here. That's me. If you know anything about me, is that probably I spent all around almost 10 years working at Red Hat with a small break of 2 years at Elastic, but now I've changed jobs again. Actually, I left Red Hat this month and I went on a different company, which is called Pace Revenue. Unlike the rest of the industry, we're not firing people, we're actually hiring people. So if you're interested, do reach out after the talk. And yeah, one more thing, I guess, is like I've been coming to this conference for so many years that my wife actually decided it was easier for her to help in the conference and contribute than getting me to not come. So if you like the plants and all the landscape designs and the garden, you have her to thank. This is not coming from the hotel. This is all planned by the conference, and it's all being contributed. So do reach out. And with that, I just earned like 10 husband points at least. So that's good for me. I just want to make sure that she watches the first 5 minutes of the talk. So simplicity or complexity, what are we actually defining? So if you're here, it's because you want to know what simplicity is. But before we know what simplicity is, we have to actually dive into the complexities of all the things that we have to face on a daily basis. So I'm going to be talking about complexity, simplicity, and I'm going to be saying things many times, mostly because I don't want to talk about a product. I don't want to talk about an HTTP API. I don't want to talk about a CLI tool. I want to talk about problems that are complex to solve and that we need to solve in some way so that others can approach them as well. But I am responsible to keeping you awake for the next 30 minutes. So I am not going to hold you here for 30 minutes and then give you the definition of what I believe the simplicity is at the very end. So I'm just going to right off the bat tell you that to me, to simplify something is actually abstracting all the complexities that there are in that specific problem. You get a problem that is very complex, you understand all the complexities of that specific problem, you break it apart, and you start simplifying it. Which doesn't mean that you're hiding everything of those complexities. Like some of those complexities are still going to go through, and they're still going to be exposed in whatever solution and whatever definition that you find. But you are abstracting it in a way that is easier for people to approach it, right? You don't want to dumb down the things that you're working on. What you want to make sure is that those things are abstracted in a way that the knowledge needed to work and use those things that you have just abstracted is the bare minimum for people to actually be able to interact with them, right? You want to reduce the amount of knowledge that people need to actually be able to interact with the things that you're building and the solutions that you're working on. And I think a good example of that is this equation here. Don't let it fool you. I don't think I understand not even the 20 or 30% of what goes behind this equation here. But if you know this equation, if you've seen it before, is the equation that a human called Albert Einstein came up with at some point in his life. But kind of like defines the mass energy equivalence for the relativity theory that he worked on. So bear with me while in the next minute I'm just going to butcher everything that he did. But the beauty of this, like I don't need to understand everything that goes behind this equation to appreciate the beauty of it, right? I don't think he woke up one day and said like, yo, you know what? I'm just going to work on an equation. It's just going to have like 2 parameters. It's going to be dope and everyone's going to like it. what he did is actually he said like, oh, this relativity issue here that sounds extremely interesting and that I want to spend time on. And he started like breaking it apart, finding solutions for the various things that he needed to work on. And eventually, he found what he believed, and still is, honestly, the definition of, again, mass energy equivalence. And he did that by following a process, right? But in this equation, as simple as it is, there's a lot of complexity and a lot of difficult things behind it that you don't need to know to actually understand. Like, you can read enough about relativity theory to understand what this equation is supposed to do, and you maybe are good with that. Like, you're like, okay, I know enough. I don't need to just like dive into like all the details of what it's exactly doing to actually appreciate what it does, unless you really like it and you enjoy it. So why is this really important? Why are we trying to simplify things? One of the reasons is because we need to make things more mundane. And this is, mundane is probably a bit of a harsh, extreme, borderline crazy way to define what I mean here. But it's on purpose. We need to start making things more boring so that we can start focusing on other stuff. Like, we cannot keep navigating the entire world with all the complexities that it has. And we need to make them easy for people to use. We need to make them easy for people to interact with so that they can focus on the things that they really care about. And I guess one other extreme example, like as software engineers, we really like going around saying like, yeah, one of my jobs is automating my job away, right? As product designers or like people working on complex systems, our job is actually to make them simple so that they become mundane for people to use. And a good example of this is imagine a doctor that needs to operate on you, right? And they need to use like a new arm that is like has a lot of software and a lot of hardware in there. Like, you don't need the doctor to understand exactly what's happening in that piece of machine. You need the doctor to just like focus on not killing you. And the way that the doctor can do that is by you like extremely simplifying the interfaces that he has to interact with, he or she has to interact with, so that he can keep you alive and like complete his job properly, so that you can walk away in one piece. But again, we need to focus on, like, part of the goal here is to focus on making things as mundane as possible, as simple and approachable as possible for other people. And I don't really pretend to know like all the complexities that you might be dealing with, but I would dare to say that this can also be applied for even your own life to great extent. Or as Nassim Taleb put in his Skin in the Game book, simplicity can, sophistication can at some times be extremely degradable, I guess, or can degrade the value of the stuff that you're building. He was not talking about complex system. He was not talking about building solution. He was basically talking about putting yourself out there and like having skin in the game on the stuff that you're investing on. But I found it extremely interesting how simplifying systems that seem to be extremely sophisticated and complex for other people can also help into making everything more approachable. And we can say that about many things in life right now, like even whether it's like investment itself, like software solutions and like CLI tools, anything like that. You want it to be as powerful as possible, but you don't need it to be extremely sophisticated for you to have the tool and consume it. Okay, so I've roughly kept you already for 10 minutes awake about like this philosophical rant. So I'm just gonna go into some more specific mental models that I believe can help with the whole thing. Some of them might sound obvious, so bear with me. But again, like this is not a checklist for you to just like follow through and have everything solved. So the first thing that you need to understand is like who you're simplifying for. And nowadays we tend to always define the persona. We always tend to define a specific type of user, excuse me, that is going to be using the tools or like approaching the stuff that we're working on or simplifying. And that is all great and fine. You define your admin user that is using your cluster, like, or administrating your cluster. You define the user that is consuming your API. You define the user that is consuming your product. But we need to take it a step further. And product managers in the audience, if there's any, are gonna say like probably, okay, yeah, that's basically part of my job. But these days you'll often find that in every product manager call, there's always a UX designer or like even a UI designer. And the reason is because the product manager cannot hold like all the knowledge. They can collect their requirements for users. They can collect a lot of information from the outside world. But the ones that are holding the knowledge of how the system actually works are the ones that are actually doing the whole implementation. So people that are analyzing the way users actually interact with your product, people that are analyzing how the UI is being built, people that know how the backend actually works. So you need more people to actually understand all the complexities of the system that you're building so that you can properly build a solution for your users. So you need to know the personas that you're talking, the ones that you're building the solution for, but you also need to get involved. Like, you also need to get other people involved so that you can understand better where they're coming from, what their needs are. Because users can have a lot of requirements. They can tell you exactly what they need, but the way that you implement that will really depend on the system itself and the way that your product works. And again, in this case, it can be an HTTP API, CLI tool, whatever, like a UI, whatever you need. Everything has a user experience. Everything has an interface that you need to interact with. And I guess on this point, actually, never mind. Let's go on. Make no assumptions. Otherwise, I'm just going to rant for another half an hour and not get on with my talk. So make no assumptions about your users. So we talked a little bit about you need to know your users. You need to know who the personas that you're working, building the solutions for are. But it's very important that you make no assumptions about how they interact with your system. And again, this is why we're bringing on other people from other teams so that we can all analyze the way that these users, these consumers are interacting with our stuff. And the same thing, like even if we go back to the equation example, like I don't think Einstein was worried about who was approaching it exactly, like who was going to use the equation. But I'm pretty sure he was concerned about who was going to read it and whether they were going to be able to understand what he was trying to explain. And that's another way to just make no assumptions about who's going to consume your information or even how you're preparing the information for them, right? You want it to be easy to consume. And the same thing applies here. Make no assumptions. You don't know the amount of knowledge that they have. You don't know what their background is. You don't know exactly how they're going to be using your software or the stuff that you're building. So it's extremely important that you not only collect requirements, but you also collect feedback so that you can iteratively improve the system and make it simpler. You should make fewer assumptions about the environment, and fewer is intended here. I think there are some assumptions that you can make about the environment. It's common to say that you should not make any assumptions about the environment, but that basically means that you will have to validate everything about the environment and the ecosystem where you're running from. And in this case, I am going to use software as a very specific example. So if you're running a service and you make no assumptions about the environment you're running on, then you're probably going to spend on probably half an hour of the boot time in pre-flight checks, validating that you have a file system, that you have network connectivity, that you have a bunch of other stuff that are already like a prerequisite for your software. So you can have a list of prerequisites and you can make some assumptions. Like another kind of like extreme example is if you're using any cloud service and you're using their storage service, you have to be failure tolerant for sure. But if you, granted that you have all the permissions, all the buckets exist, and that you can write to the storage itself, you can assume that you're not going to run out of space. Like if you run out of space on S3 or GCS, then we have a bigger problem in the entire world. And your software is not the only one that's going to go down. So there's some assumptions that you can make, but you have to be extremely clear on what assumptions you're making and why you're making them, so that those can be simplified away from whatever checks and whatever stuff that you're building, and you can focus on the other things that actually need to be validated and verified. Make it easier for the users to decide. And this relates to the very first part of the presentation where I was telling you, abstracting the complexity, again, it's not hiding everything away. If there's something that makes me extremely mad, it's like, because, okay, so I consider myself like an advanced user for most of the things. So if there's a thing that makes me extremely mad is when tools that are simplifying more complex problems or like very annoying things to interact with hide everything behind a single button. And then your only interface is that single button that will do everything for you automatically. As an advanced user, you many times want to interact with some other parts of the system. You want to have the option to decide whether you want to go in advanced mode or you want to stay with the utterly simplified version and interaction way. So in some cases, it might actually make sense. But the most important thing here is that you have to, based on your user base, based on the way that your users are going to be interacting with the things that you're building, you have to make sure that you're giving them the option to decide which way they want to go and what they need to do. And with anything in life, there's always trade-offs. There's no way to go through all these without trade-offs. So again, if you're overly simplifying and you put in everything behind a single button, your big trade-off is that you're completely hiding all the potential of the things of the problem space that you're solving the problem for. But the most important thing about trade-offs is not the fact that they exist and the fact that you have to deal with them. It's the fact that you need to know them. And the only way that you can know what your trade-offs are is by completely understanding the complexity of the problem that you're solving. If you completely understand the problem and you make decisions based on all the information that you gather, then you're going to know what your trade-offs are. And then you have to go and document them properly so that you can give your users the option to decide exactly what they need to do. And I think all of these, what really is a case in favor for comfort zones, really. And I do want to spend some time here. We tend to push ourselves a lot out of our comfort zone. And when you tackle a new complex problem, you're pushing yourself into something that might make you uncomfortable. Like you're trying to solve this problem and make it easier for people to use. It gets you out of your comfort zone, especially because you're not only tackling something that, it may be exciting for you, but you're tackling something that you're maybe not an expert on. It's a hard problem. You need to solve it. You need to spend money or time or whatever you want to say. And you're also building a solution that is not necessarily going to be perfect for the users that you're, or the people that you are targeting, and you'll have to accept that, right? You'll have to iterate, you'll have to make it simpler and simpler every time. But the case here for comfort zones is that what you're really after is creating a comfort zone for those people, right? You want to make them feel comfortable. You want to make them feel cozy in whatever solution you're building so that they will never leave. Going back to the doctor example, you want the doctor to feel comfortable with the tools that he or she are using so that they will stay, they will keep using them, they will keep providing you feedback so that you keep improving your software. So there's nothing, like, comfort zones are not necessarily entirely bad. Like we talk about them as something that we should always avoid as much as possible. But the truth is that it is good to have a comfort zone for many things in life, and there are some other things that you do want to push yourself out of the comfort zone for. All right. How far should we take it? This is a tricky question. And again, it really depends a lot on your target audience and the problem that you're trying to solve. But all right, so it would be irresponsible of me standing here showing you the Einstein's equation and not quoting him. So I decided I was going to put one other quote from Einstein. And this is probably one of the few quotes that can actually be attributed to him, unlike the other 1,000 quotes online that don't make any sense. So Einstein once said that everything should be made as simple as possible, but not simpler. And it's a tricky thing to analyze, and I'm not going to stand here telling you that I understand exactly where he was coming from. That would be irresponsible of me. Also a massive lie. But he did that. He said that related. Sorry. He said that related to a lot of his work and a lot of the questions that he spent a lot of time simplifying, and a lot of the problems that he spent a lot of time explaining and defining and making available to people. And the important thing here is that we need to simplify things as much as possible, but we need to make sure that we're not dumping down all the stuff that we're working on. Like, you don't want to make it feel like allow me to say, stupid for other people to approach the problem, really. There are some problems that are just complex. And again, like what we're trying here, like what we're after is to make them more approachable to people. So how far should you take it? It really depends on the problem space that you're solving and the things that you're working on. And I guess the next thing is like, okay, so we don't really know how far we should take it, but how do we know if it is simple enough? And once again, like this is a hard question that honestly, I don't think I have a perfect answer for, but the best thing that I can do is give it to you as a mental model as well, as something that you need to keep iterating on every time that you're working on something, and keep asking yourself whether something is simple enough or not. And the most important thing to remember here is that I don't think you will ever know if something is simple enough. What you can know is what people will tell you once they start interacting with the things that you're working on, right? Which takes me to something that Gilles Deleuze said once, or wrote in one of his books, and probably is one of my favorite quotes from him, and is that technology is social before it is technical. And this basically means, he said it in a different context, to be honest. It was more related to having communities. It was more related to sharing software. It was more related to other things that he was interested in. But I think it applies perfectly on the topic that we're on right now, which basically means that you don't really ever know whether your software and the things that you're building are simple enough for other people to use until you actually have them use it. Right? So what you really want is to go to market as fast as possible, get it out of the door, and have people consuming the things that you built, and then collecting feedback and iterating over and over and over and over again until you make something that is comfortable enough for people to stay and to keep doing the, working with you on that cycle and giving you as much feedback as possible. And as a very last slide, and surprisingly enough, we are actually going to have time for questions later. I'm going to leave you with this, which is, of all the things, is what actually triggered me into diving more into this topic. And I did warn you that I was no exception for people, the 8 other billion people in the world that did sourdough during COVID. I did sourdough. I have my own sourdough. I do bake bread now. But one of those days, during one of the bakes, I was measuring the flour as you would normally do when you're baking breads. And it hit me that I was spending, because science and we're engineers and we would like to be precise, and okay, this is another way to say that I have a massive OCD. You want things to be precise, so you're there and you're measuring your flour, and you just like, you want like 350 grams of flour. And it hit me that as Europeans, we're really proud of our metric system, I'm going to say our, although it's not really ours, but it's really ours. Metric system, and we like the way that we measure things. We like it because it's precise. We like it because it's repeatable. And we tend to rant about other measuring systems, and yes, I'm talking about the US, and how imprecise they are, how difficult it is to replicate if you're all not talking about the same language. But there's one thing that you have to grant to other volumetric, let's say, measuring methods, and is the speed and simplicity that they provide you with. And to make it more clear, I'll tell you that scooping 2 cups of flour out of a bag is always going to be faster and easier than measuring 350 grams of flour. I'm not saying the volumetric measurement method is better than the metric one, but that is something that the metric system is never going to beat. And that is part of, I think that's a good example of what having trade-offs means, what your priorities are, whether it is simplicity, speed, or repeatability and reproducibility, and what a good API or let's say API or way of interaction with your users is. So I'm just going to leave you with that. Think about it. Use it as a way to reason about your problems and navigate the complexity of the things that you're working on. And I just thank you for being here.
So we have a question, and it's, can you give us a concrete example in which you successfully obtained simplicity from a complex project?
Next question.
There are none. Sorry about
I'm
that.
just kidding. No, so, that's a difficult one. It's difficult because you never know if you actually build something that is extremely simple enough. But I guess the most valid example that I have right now is what we're doing in the new company that I joined. I joined as a platform engineer at this point, and we're building, one of our main goals at the company at this point is allowing people to self-serve their own infrastructure, right? And we wanted to make it super simple for them to create their own clusters, have their own databases and everything through code in a way that is repeatable. And especially we wanted to avoid them to be clicking on the Google Cloud interface because it's just untrackable and crazy bananas. I'm glad to say that I think we're succeeding on it. I don't think it is simple enough, considering that Terraform is not widely known at the company yet, but the process itself is simple enough. It's basically, for now, hopefully it's going to be simplified a little bit more later based on the feedback, but for now you basically go, copy a directory, change a few parameters, commit the code, and then magic happens. So I think that's my current best example, honestly. I don't know if that is exciting to you people, but it is for me. It's paying my salary.
That's it.
That's
Thank
it.
you so much
Cool.
for the talk,
All right.
Flavio.
Yeah, my pleasure.